Welcome to Robo Success, the podcast that loves robots, marketing, and success. Here we spotlight the innovators building the future of robotics. Hit subscribe, share with a friend, and let's get started.
Hello, everyone. Welcome to the Robo Success Podcast. My name is Jesica Chavez, and today I have a very great guest and friend, Pedro Milcent, who is the CEO and co-founder of the Deplace AI. So thank you, Pedro, for being here in this podcast. And tell us a little bit about yourself, your company, and mostly about what are you talking today, because I feel the topic you're going to be talking is super interesting, and I'm going to tell you in a few minutes why. But I would like you to introduce yourself and tell us a little bit more about you.
Perfect. That sounds good. And thanks as well for having me, Jessica. Let me tell a little bit more about myself. So I'm the CEO and co-founder of Deplace. We created a company around 7, 8 months ago, me and my co-founder. And the work that we do is very much related to actual physical AI and robotic deployments. We think that this is one of the main goals that robots are gonna actually get out of the lab and into the factory floor, into warehouses. And for this, a lot of different components are needed. You need a much better physical AI evaluations of actual real world cases. You also need a real targeted data for those deployments so they can actually reach the level of performance that is needed for physical AI to be utilized in industry. And those are all some of the matters that we work with and help our clients.
Thank you, Pedro. So, yes, well, I have also to be adding that Pedro is originally from Brazil. And I have to say this because as a Latina, I always like to be helping people that is from Latin America. I always, enjoy seeing these people in this industry. And what I really was interested to talk about you in this topic is, as you many know, as a part of the Humanoid Summit, I have been involved in a lot in the humanoid industry, right? Where
Yep.
I see that we have been trying to develop a lot of these technologies to be ready for the warehousing, to be ready for the manufacturing or other areas. And also we have seen now this trending or calling it physical AI, right? Because they we're moving from being just a machine to be now trying to make them smart machines, and we are using AI for that. So I think it's important to understand that we see a lot of videos of robots or humanoids doing things, but it still needs to be happening a lot for that data for those robots to be able to do it, right? So for here, I have a few questions for you. The first one would be is like, what do you think is the current performance of physical AI in real tasks?
That's actually, I think, a great question for us to begin with, because a lot of people they do exactly what you described. They see humanoids doing backflips and doing all those kind of very impressive visual demonstrations and videos, and they have this wrong impression that humanoids and physical AI is already, let's say, much more developed than what it already is. They think that robots can already automate pretty much anything that a human can do in a factory or in a warehouse. And although this is becoming more and more the case, we're not yet there. It's very important for people who are working in the spaces where physical AI is actually going to be deployed, warehouses, industrial centers, etc., to know what's the actual performance that physical AI is going to have for their specific use cases, for their specific objects, for their specific industry, their environment, their lighting. That's a little bit of the work that we do. It's very important to have this analysis be done on a case-by-case basis, because today the way the physical AI work is that it's very much related to the work that researchers do on their labs. So sometimes you're going to see, for example, people saying that they're able to have a 99% picking accuracy. A lot of the times that's actually true, but that's true for that specific use case that people do in the lab. What industrialists actually want to know is, okay, what's the performance of physical AI solutions in my case, in my warehouse, with my objects? And that's something that has to be analyzed on a case-by-case basis. And that's the importance of physical AI evaluation and targeted data.
Yeah, and I think I will also add that when you're saying like, oh, we see that they do these flip ups and all that, right? I can say even from my daughter, right? Like they are even afraid that they are gonna do something more than that. And people need
Yeah.
to understand that they need a lot of data, right, in order to be able to do sometimes even a single task. Like the other day, I was visiting Albionics office, right, and I was talking with one of the engineers, and they were telling me that took them like 2 or 3 months for the program to do some specific picking for a specific piece with the hand, right? And you
Yeah.
see in the hand the picking, and you see, oh, that's easy, right? Like everybody can do picking, right? But imagine all the data, all the training that needs to happen. And also this delayed also getting your product to the market, right? You can have
Yeah.
amazing hardware and amazing things connected and so on. But this also impact the market in how ready you are really to deploy. When a customer come to you and say, hey, I need your product to do ABC, and you are not ready for that, also you don't have really a product to sell, right? You have just a
Yeah.
prototype. So what will be the initial use cases for physical AI being deployed in the real world?
Yeah. There's also a good point for us to talk about, and what you said is 100% true. Doing backflips is actually much easier than doing those actual pick and place tests, and that's because if you think about when you are picking an object, maybe any type of object, something like this, there's so much information there in the way that you position your fingers, the force that you utilize, just a little bit less force, and it would let this object drop. So those tasks that are the tasks that are relevant to industry that goes through your question, uh, those are the main things that physical AI and robotics companies are working on. They're working on those picking tasks, on folding tasks, on packaging tasks. And what this means is that the first industries that are going to see more physical AI automation are mainly logistics and manufacturing. So when you think, for example, of logistics, think of all of the warehouse tasks that exist, the hundreds and thousands and likely millions of people that work in packaging items that are purchased for e-commerce, of a consolidation of items, putting different items of different sizes, textures, weights inside boxes to be shipped to people's homes. Today, a lot of those jobs are still manual because they are too variable and too flexible to be automated through traditional robotics. However, through physical AI, through all of those advancements that we have been seeing, that's the first line of automation for physical AI robots.
Yeah, yeah. And did you have like an estimate in your experience? Like, let's say right now there is a company ready to deploy, right? Let's say an arm, not necessarily a humanoid. How long can take, for them to train, that physical AI?
It's a very iterative process today. So everything begins in actually evaluating the tasks. So, for example, saying a warehouse out of the 100 workflows that they have, what are the 5 workflows that are the best ones for us to actually evaluate and see what physical AI can actually do there? So, even to decide what to evaluate, that's the first thing, and that can take a couple of weeks to evaluate what's the performance of different physical AI models for that specific task. And once we have selected a specific partner that is good for that specific workflow, then we have to find what are they good at and where are the gaps. So what's their success rate today for this pick and place task, for example? What are the objects that they fail most of the time? Is the issue mainly due to to a lack of diversity in the data? So we need data with more lightning, with different ways of positioning the data set, position the object itself. So it's an iterative process in which you have to see where the gaps are, and then you have to collect the best data to go and fill those gaps. So it begins with evaluation, then goes into data collection, and then of course it's a process of doing more and more evaluations as much as you can in a similar setting to where the robot is going to be deployed. So if we're doing this in a lab, making it as physically similar, almost like a physical twin to the actual environment, and then of course a real deployment happening inside that warehouse, inside that factory, so that you can see with all the actual aspects of the environment how the robot actually goes and perform. And then after this pilot, we can take anywhere for a couple of months we have seen pilots that take 6 months or even more. After this happens, then you can actually begin thinking about an actual automation of that specific task. We're seeing more and more physical AI companies going in the direction. Some are more advanced than others, but that's pretty much the different steps that they have to take: evaluation, data collection, more evaluation until you actually get into the deployment.
And I think this comes with another question, like why is data fundamentally harder, and more expensive to collect for physical AI compared to digital, right? Like we keep hearing data, and we need to
Yeah.
collect it, right? And we keep seeing that there are a lot of robots of physical AI that are behind, but I feel it's kind of because of this bottleneck.
Yeah, that's an amazing question. And when you think of the data for LLMs, for the world of natural language, the data that they already had was the entire textual corpus of the internet, every single text that was ever written. So you already had a very large amount of data, and this data is pretty much in one type of modality, it's textual data. The data that we need for physical AI is real data in the real world. And what this means is multiple modalities. This means visual data. So, for example, people performing tasks, what's the trajectory when I do a specific task? But it's not only visual, it's also tactile. What's the force that I'm utilizing? It's also the sensory information that you can get, for example, from robots when you do teleoperation, what's happening within their different joints. So it's many different modalities of data that you need to collect because robots, they don't work in the digital world. They don't work in the world of bits. They work in the world of atoms. And the real world is very harsh, let's say. If you do a tiny mistake in terms of a force, for example, the object drops. So if this is happening in a factory, this means that if you're handling objects that are fragile, for example, that they break. If you put just a little bit more force than you need, a box, if you are talking about a packing test, for example, means you're going to damage the box and then you're going to have to redo it over again. So you have to be much closer to perfection, to 99% performance if you are to work in the real world. While for textual data, we have seen ChatGPT just a couple of months ago. It's getting better and better, but in the beginning, it had those weird phrases. But that was good enough for us because some human could go and make some of those changes. The physical world is much harsher, so and it has much more modalities of data. So that's why data is more important in the physical world, and it's harder to go and acquire all this quantity because of all those different modalities.
Yeah, that's super interesting because, like, if we think about it, right, we're trying to imitate what for us humans is normal, is natural, right? Like you say, no, grabbing a pen and just write, right? And thinking like all the data that needs to be collected to do that simple task is a lot. So when people is afraid that all robots are gonna take over my job, that's gonna be quite a bit, right? Because they need to, in terms of doing that, learn all the things that for us are kind of normal or natural. So, what happens to physical AI development when data remains kind of scarce, difficult to get, or high cost? What really is the impact there?
The direct impact is performance. If you don't have enough data, it means that your model has a much harder time generalizing. And I would say that generalization is one of the most important goals of robotics today, because you don't want the robot to work on only one object in only one space. That's what we already have traditional robotics for. That's why you have programmatic robots. You program the robot to always use the same force, pick the same object. It can do this very well today. We have the entire robotics industry, the traditional robotics industry for that. What we want physical AI robots to be is that if you put objects that have a lot of that are very different, they have a lot of variables there, so different sizes, textures, formats. That even though the robot was not trained on that specific object, it has never seen that specific, it has not been programmed for that specific object. It's going to be able to pick it, pack it, manipulate it in different ways because the original data set that it was used to train this robot was sufficiently large that it can generalize to new objects, new spaces, new environments. And that's the importance of data there. Until we reach this level of quantity and diversity as well, which is quite important for data, we're still gonna see some lacking results in terms of generalization. That's also why it's quite important when you're thinking about actual physical AI deployments to have targeted data because the industry, just like robotics, is very harsh. Nobody in the industry wants a robot that only works 85% of the time, even though this is very impressive for research. If you are an industrialist, if you have your warehouse, you need this to work at least 95%, 96% of the time. So this means that data from that specific space is very, very valuable for you to be able to have the robot reach the level of performance. So yeah, generalization and performance.
Yeah. And I think like one of the things that people need to understand is that physical AI or robots now, they cannot be, a robot without data. That's it, right? Like you say, like I would say generation before robots, right? You can just program them and everything. But now what the market is asking, right, is having, I would say, a smarter robot, a more generalist robot. So, what are the most promising ways companies are reducing the cost of real world data today? How they can
Yeah.
access?
So originally, the main way that physical AI companies gather data for their models was through what's called robot teleoperation. So someone actually operating the robot, so the robot could do the task. And that's considered, let's say, the gold standard of data in terms of quality, because you have all of the sensors from the robot, from its joints, a lot of the times the force information. It's a very precise data, let's put it that way. But it's also very expensive and very limited because you need an actual robot to go and collect it. And those robots, they are quite expensive. They can easily cost $30,000, $40,000. It's very hard to put them in very different environments with different objects, which means that for robotics companies to have the quantity and diversity of data that they need, you have to look into alternative sources. What are those sources? A lot of people are looking more and more into human data for robotics. So this means data video, for example, a lot of the time of people performing actual manipulation tasks. And that, of course, is much easier and much less expensive to collect. That's one of those alternative sources. That's one of the ways, for example, that we collect data. You also have people that work with simulation. So using simulation engines so that it can collect data in this manner, which is also quite interesting. Has some issues, challenge, let's put it this way, when it comes to make the simulation as close as possible to reality. It's what is called the sim to real gap, but it's also getting better and better. That's another alternative. And you also have people working on world models. That's something that I would say is a little bit farther away, but is also quite promising. At the end of the day, the data mix that companies are going to use to train their models is much likely going to be a mix between those different modalities. You're going to have some robot operation as an anchor to the model. You're going to have a lot of human data as well, so you can have this quantity and this diversity. You're going to have some simulation as well, especially for edge cases that you would not like to collect in the real world with fire explosions, for example. It's just one of those examples. So it's going to be a mix between all those different modalities, but especially using those alternative sources to have the quantity and diversity that you need.
Okay. Yeah. So, what do you think, or how do you think Deplace AI is helping with all these challenges in the data market for physical AI?
Yeah. For us, it's very important to help with real use cases. So it's very important for us to be working with actual deployments and not only doing the data collection, but also doing model evaluation. This is very important for us because it allows us to see where the gaps of the models are. This is vital if you are someone in industry that wants to deploy robotics. You want to see, okay, what's the actual performance that this robot has on my actual task. So it also helps the robotics companies in a way as well, getting clients into deployments, which of course everyone likes. That's one of the points, and also knowing the gaps. So this way, when we are collecting data, we can know which data to collect. This allows us to be much more precise and also collecting data that is not a generalist data set on any task, on any object, but an actual data set that is going to be used for that specific industrial deployment and industrial use case. So I'd say that's the contribution that we aim to make more and more in the industry, helping robots get out of the research labs and more into those factories and warehouses.
Absolutely. And I think is now what a lot of these companies need, right? Like they are ready to start, as a marketer, I always say like, let's get your product ready to be in the market, right? Be ready with real customers, get real feedback. Because what happened in the lab, of course, I mean, yeah, don't take me wrong. You need the research, you need to have them in the
Of
lab.
course.
But now you need to understand really what are those real cases, how you can really improve that. Because if you have your robot too long in the lab, well, it's just a research robot and that's it, right? So looking ahead, like what do you think is going to happen or who can be preventing having this bottleneck on the data? So start becoming really an accelerator for these companies to keep deploying and scaling, not only the mass production, but also the mass deployment in real work cases.
Yeah, it's all a question of timing, and I agree with you. Everything begins in the lab, and I think that if now and in the next 1 and 2 years we are seeing more and more people working on pilots, doing actual deployments, all of this is thanks to all the great advancements that we have seen that came out of research from amazing universities, CMU, Berkeley, Stanford, and many others. It's because of those advancements in physical AI and the improvement in performance that we saw on the labs that now we can even be talking about pilots and about deployments. And that's exactly, I would say, the vision that we have for the next years. Physical AI is going to continue to get better. Data is going to continue to grow. Those models are going to get just better and better, which means that naturally deployments are going to be much and more numerous. You're going to need to actually go and have this work of when we're actually deploying those specific use cases, improving them more and more so that you can do an actual automation job so the robot can I would say do what the research began, what was let's say planted when the research happened, and now it's actually becoming a reality. So this is only going to be growing in the next years. I think even in the next 12 months we're going to be seeing a couple of very good and interesting examples of physical AI robots actually deployed and having actual economic and business value for industry.
Yeah, great. So, Pedro, I think we are getting to the end of this podcast. I think I can keep talking about this. I really, enjoyed this topic because, again, like I keep saying or keep getting asked, like, oh, I see the robot is doing this. Did you see this? I think robots are getting ready to do this. And as someone who works very closely with all these companies, right, I know that they are still working on how to really get them out there in real
Yeah.
life and making sure that they are really adding value to all these different industries. So thank you again, Pedro, for being here. I don't know if something else you would like to add before we're leaving. And I have only one more question, but I would like to let you to talk if you want to add something else.
Yeah, I'd like to thank you again for this opportunity and to talk a little bit more about this topic, which, of course, is also extremely interesting. I think that the entire society is seeing more and more of what robots are able to do, are becoming able to do as well. And this is going to be a very big factor for not only the economy, but also people's lives. You have some amazing companies as well working on robotics for households, amazing companies working for robotics and physical AI for services, a lot of working for physical AI for industry as well. There's going to be a very big part of the economy in the coming years. So being able to be a part of this in those early stages is quite rewarding.
Yeah, and I will also add that please follow what Deplace AI is doing. So make sure to follow. I'm assuming you have in LinkedIn and everywhere, right?
Everything,
Yes.
yes.
Perfect. And the last question I have for you, do you have any favorite robot? It could be one that already exists, it could be from a movie, anything.
That's a good question. I would say that I'm really impressed by robotics companies that are actually able to show the robots doing something that brings an actual business case. I really like anyone else. I love seeing robots doing backflips. But what actually impresses me the most is what you said actually in the beginning is when a robot folds a t-shirt, when a robot grabs a cup. People who are in the industry know how hard and how difficult it is to actually go and do those tasks. So when I actually see a video of a robot grabbing a cup, a glass cup, and not letting it drop, that's what makes me smile. So there you go. I'd say those types of tasks in robots.
Yes, absolutely. I agree. Well, Pedro, again, thank you so much for being here. Appreciate, your time and well, looking forward for another second episode with you sometime.
Of course. Thanks again.
Thank you.
Thank you, Jessica.